Welcome friends. In this video, I would like to discuss about the topic testing of difference between mean for dependent samples. So for testing this difference between dependent samples, we mainly use paired t-test. So what is paired t-test? Paired t-test is a statistical test used to compare the means of two related samples or matched pairs. It is used to test a hypothesis about the difference between the means of the two samples. It is based on the assumption that the difference between the pairs are normally distributed. So this pair test is mainly known as a statistical test, and it is used to test the difference between two variables from the same subject. So sometimes it is called the dependent sample t-test. So mainly there are two types of sample t-test. First one is dependent sample and the second one is independent sample. So coming to dependent sample is also known as unpaired t-test. It is used to compare the sample means from two related groups. The purpose of this test is to determine if there is any change from one measurement or group to the other. So the next type is independent sample. Independent sample is also known as paired t-test. This independent sample t-test compares the means of two independent groups in order to determine whether there is statistical evidence that the associated population means are significantly different. Next, we are going through a small example because mainly our topic deals with the testing of dependent sample. So in this example, we have to determine whether a new training program improves the performance of individuals. For this, in our hand, we have the data of performance of 10 individuals before and after they undergo the training program. So for testing the hypothesis, mainly we have 5 to 6 steps. So first one is to setting the null or alternative hypothesis. In second step, we have to calculate the difference between the paired observations. In third steps, we have to find sample mean and standard deviation. In fourth, we have to calculate the t-value. And in fifth steps, we have to find the critical value and p-value. And at last, we have to make the decision whether to accept or reject the hypothesis. So coming back to the solution, first step we have to set the null and alternative hypothesis. Null hypothesis is denoted by h0 and alternative hypothesis is denoted by h1. So null hypothesis is that there is not a significant difference in the mean performance before and after the training program, and the alternative hypothesis is there is significant difference in the mean performance before and after the training program. In the second step, we have to calculate the difference between the paired observations, like our 10 individuals before and after performance. So our d is equal to first individual 85 minus 78, second one 89 minus 82. Like this, we have to calculate the difference of 10 individuals. So in the third step, we need to calculate the sample mean and standard deviation of the differences. So we all know that how to calculate the sample mean as x bar is equal to sigma d by n. So here the sigma d means the total of all differences and the capital letter n means the total number of samples. So here we have total 10 number of individuals. So the n is 10. So our sample mean is equal to, by calculating we get 5.3 as our sample mean. Next we will find out the standard deviation by using the formula root of sigma xd minus x bar d the whole square divided by n minus 1. Here xd means the differences of the samples, x bar d means previously we find the sample mean as 5.3, and below the denominator as n minus 1, n means the total number of individuals as 10. So n minus 1 is equal to 10 minus 1 is equal to 9. After calculating, we get the standard deviation as 0.74. So in the fourth step, we have to calculate the t-value. For calculating the t-value, we use the formula t is equal to d bar minus mu divided by standard deviation by root n. So mu in this case we have 0. So by substituting the mean, standard deviation, mu and n, we in this formula t is equal to 5.3 minus 0 divided by 0.74 divided by root n as 10 is equal to, we get the t value as 16.42. Fifth step, we need to find the critical value and p-value. For finding the critical value, we need to find the degree of freedom. For finding the degree of freedom, degree of freedom is equal to n minus 1 is equal to 10 minus 1 is equal to 9, and here the significant level is equal to 0.05. So while comparing this with the statistical table, we got the critical value as 2.262. Next step, which is our final step, is to make a decision whether to accept or reject the null hypothesis. For this, we need to compare the t-value with the c-value. Whether if the t-value is beyond the critical value, we need to reject the null hypothesis. Otherwise, we fail to reject the null hypothesis. In our example, the t-value is 16.42 is much larger than the critical value 2.262, so we reject the null hypothesis. So this suggests that there is a significant difference in the mean performance before and after the training program, indicating that the training program likely had an effect on the individual's performance. So friends, it's time to wind up our section. So in this section, we discuss about what is paired t-test, dependent and independent samples, and mainly how to test difference between mean independent samples with a small example. So you guys all enjoy this section. Thank you all. Have a nice day.